Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that appeared in the CSIR National Eligibility Test held on February 28, 2025. Today, we discuss the solution of a problem from the section Linear Algebra, and the problem is related to the concepts of orthonormal basis of a vector space of an inner product space. This question is placed in part C, which is a multiple select question, and there can be more than one answer. The question carries 4.75 marks. The question ID is 704157. This question is suitable for all these examinations. Right. The given question is, let V be a R vector space. R vector space means vector space over the field of real numbers. Let V be the R vector space of real value continuous functions on the interval closed and bounded interval 0 to pi with the inner product given by the inner product of f comma g is equal to integral 0 to pi f of x g of x dx. Let S be the set consisting of sin x, cos x, sin square x, cos square x, and W be the subspace of V generated by S. Which of the following statements are true? We are given four options. Option 1, S is a basis of W. Option 2, S is an orthonormal basis of W. Option 3, there exists f comma g belongs to S such that the inner product of f with g is 0. Option 4, S contains an orthonormal basis of W. Right. Let's now discuss the solution of the problem in detail. So, we have V, that is C0, C, closed and bounded interval 0 to pi over R. Continuous real valued functions is a vector space over R. And the inner product is defined like this. The inner product of f comma g is integral 0 to pi f of x gx dx, and S is given by the set consisting of sin x, cos x, sin square x, cos square x, and W is the subspace generated by S. That means it is the linear span of S. Now, option 1 says S is a basis of W. S will be a basis for W provided S is linearly independent over R. So, let alpha, beta, gamma, delta be scalars. Scalars means belongs to R. And alpha times sin x plus beta times cos x plus gamma times sin square x plus delta times cos square x is equal to 0. True for all x belongs to the closed and bounded interval 0 to pi. Right. We take x is equal to 0. Substitute. Sin x is 0. Cos x will be 1. Thereby, we get beta plus delta is equal to 0. X is equal to pi. Then sin pi is 0. cos pi is minus 1. And then we get minus beta plus delta is equal to 0. Beta plus delta is 0. Beta minus delta is equal to 0. Solving, you get beta is equal to delta is equal to 0. Now, we take x is equal to pi by 2. Sin pi by 2 is 1 and cos pi by 2 is 0. Then we get alpha plus gamma is equal to 0. So, yes, we take x is equal to pi by 4. Then sin pi by 4 is 1 by root 2. Sin square pi by 4 is 1 by 2. And cos pi by 4 is 1 by root 2. But beta is equal to delta is equal to 0. Therefore, we take only alpha sin pi by 4 plus gamma sin square pi by 4 is equal to 0. That is alpha by root 2 plus gamma by 2 is equal to 0. This will imply gamma is equal to minus root 2 alpha. Alpha plus gamma is equal to 0. Gamma is equal to minus root 2 alpha. From these two, solving for alpha and gamma, we get alpha is equal to gamma is equal to 0. Thus we got alpha is equal to beta is equal to gamma is equal to delta is equal to 0. So we get this one. So this means this says that this set S is linearly independent over R. Right. S is linearly independent. S spans W. Therefore, S is a basis of W. S spans W. S is linearly independent. Therefore, S is a basis of W. Thus, we have proved the option 1. So, thus option 1 is true. Right. We move on to the next slide for the discussion of the remaining options. Right. 3. Option 3. There exists f comma g belongs to S such that f comma g is equal to 0. Yeah, very clearly, you take sin x and cos x and take the inner product, that will be 0. Let f of x is equal to sin x, g of x is equal to cos x belongs to S. Then the inner product of f with g is integral 0 to pi f of x gx dx, that is equal to integral 0 to pi sin x cos x dx. And integrating you will get sin square x by 2 to be evaluated between 0 to pi. Then this will be 1 by 2 sin square pi. Sin pi is 0 minus sin square 0. So it is 0. So the inner product is 0. Therefore, they are orthogonal to each other. So there exists fg belongs to S such that f comma g is equal to 0. Thus, option 3 is true. Right. We move to the next slide. Option 2. S is an orthonormal basis of W. Now, S is a basis of W, which we have already seen in option 1. And to make S to see whether S is orthonormal or not, first of all, S should be orthogonal. What do you mean by an orthogonal set? A set, S is said to be orthogonal, then every pair of vectors or elements in S are orthogonal. So, I will take two functions, sin x and sin square x. Are they orthogonal? So, let fx is sin x, gx is sin square x, both belongs to S. Then, the inner product of f with g is integral 0 to pi sin x sin square x dx. For sin square x, we have written 1 minus cos square x. Then, the integral becomes integral 0 to pi sin x dx minus integral 0 to pi sin x cos square x dx. Integral sin x is minus cos x to be evaluated between 0 to pi. Agreed. And put cos x is equal to t. So, sin x minus sin x dx is dt. And substituting, you will get plus cos cube x by 3 to be evaluated between 0 to pi. Now see, cos x minus cos pi minus 1 minus cos 0 minus 1 plus 1 by 3 into cos cube pi. Cos pi is minus 1, its cube is minus 1, minus cos cube 0, that is minus 1. So that will be 2 minus 2 by 3, which is not equal to 0. So they are not orthogonal. They are not orthogonal to each other. Therefore, S is no longer an orthogonal set. When it is not an orthogonal set, S cannot be an orthonormal set, and hence S is not an orthonormal basis of W. Thus, option 2 is not true. Right. We move to the last option. Option 4. S contains an orthonormal basis of W. S contains an orthonormal basis of W. That means can a subset of S be an orthonormal basis of W? We have S is a basis of W. First of all, note down this. Now, that is S spans W. S is linearly independent. That's the meaning of S is a basis of W. Now, no subset of S is a basis of W. How can you say? Because a basis, what is a basis? A basis is a minimal spanning set of linearly independent vectors. It is a minimal spanning set. Therefore, no subset of S is a basis of W. Therefore, S doesn't contain an orthonormal basis of W. Therefore, option 4 is not true. Summarizing all the options, the answer to this question is option 1 and option 3. That is the detailed discussion of the solution of this problem, which is based on the concepts of orthonormal basis of a given inner product space. Right. And it is definitely an easy problem. I am sure that you have understood the solution of this problem. Thank you for watching this video. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.